Welcome to another session of Maths Fanatics 24/7. In this question, we're going to be looking at the theorem that states the angle subtended by a chord at the center of a circle is twice the size of the angle that is subtended at a circle. Okay, sometimes they'll say at a circumference. Ne? So, but what the theorem is saying is this. The theorem says, if this chord, which is called what? AC, forms this angle here. So this one. Okay, let's get a different color. So this angle here must be 2 times that angle there. So if this is 2x, that one there must be x, right? So in this question, they're asking us to prove that this is always indeed going to be true. Okay, so we're going to do that now. Perfect. So we have to remove that because we are not yet sure that this is 2 times that. We have to prove. Does make sense? Awesome. So what do we do when we prove a geometry theorem? We always start with construction. Construction. Okay. In this case, we are going to draw a line. So we're going to say draw line B, O. We can choose any letter that is not here. Let's see. Okay, I don't have E. I can say B, O, E. Ne? And then whatever you write on your construction, you have to show here. So line BOE is this. So this is B to O. And then it's a straight line to E. E can be anywhere here. Okay. It can be any letter. It doesn't have to be E, but the letter that you choose must not be here. So I could not have chosen A, O, C, or B. Does make sense, but any letter. Perfect. And then you're going to label. We're still under construction. Still under construction. Label. Angle B1. Angle B2. Angle O1. Angle O2. So I'm going to show the labels now on the diagram. B1 is there. B2 is there. O1 is there. O2 is there. Whatever you write on the construction, you must always show on the drawing. Okay. Awesome. So now we can start with our proof. Okay, before we proceed, let's agree on something, ladies and gentlemen. We have to agree that AO, CO, and OB are all the same. Why? Because they are radius. They are lines from the center to the circumference. They are radii. Do you see them? So they have to be equal in length. Perfect. Okay, let's do this here. Sharp. So now we are going to start with this. So we have to write required to prove RTP. Remember, I need to prove that AOC, which is angle at the center, I need to prove that AOC is 2 times angle at the circumference. So it is 2 times angle B, né? Which is there at the top. Sharp. And then after that, I can draw a line and write proof now. But everything you show, everything that we've shown so far, you show there's marks for everything, right? Sharp. We're going to say proof now. So this one, we're going to prove it by doing this. No? We're going to find this angle and that one. Sharp. So I'm going to say angle A, right? Equals to angle B1. Why? Because I have an isosceles triangle here. So this angle here must be the same as that one. This angle must be the same as that one because of the isosceles triangle here, right? So you're going to say AOB is isos triangle, né? And then also angle C, this one, right, will be the same as that one. So angle C equals to angle B2, which is, you can say similarly here, similar resonance above, or okay, here we forgot to show this. So triangle COB is isos triangle, né? So if it's an isosceles, the base angles are always going to be the same. So here I have a right to say angle B1 now. Here I have a right to show that this is angle B2, né? But ladies and gentlemen, remember we're proving now. At the end, you're going to erase everything. You're just going to leave what you said on the construction only. Anything that is not on the construction must not be there. I'm just putting them there just to help you see what is happening as you solve the question, right? Sharp. So now I'm going to use this thing. Remember, if I have a triangle like this, right? This angle and that one, when I add them, they must give me this one. The sum of interior opposite angle equals to the exterior angle in a triangle, né? For example, here, O2, right? Let me try to get a highlight and let's see if we can, this can make sense, né? With a different color. So let's see. So I'm going to highlight these triangles, né? This one. Let's see, this one. There, right? So this angle plus that one must give us that one, right? So we're going to say O2 is the same as angle C plus angle B2, right? Which is the same as, remember angle C we just said is the same as B2 there, which is B2 plus B2, which is equals to 2 angle B2. And then our reason here is X angle equals to sum of int op angles. Okay, perfect. So I just proved that O2 is this, right? And then I'm going to say similarly. So with similar resonance above, O1, using that other triangle, né? That one. O1 will be B1 plus B1, which is 2B1. Do you see it? 2B1. Perfect. Now we're going to add. We no longer need, okay, let's see now. Let me get my white thing again. Okay, let's use red now, actually, because I need the space. So here, because I don't have space, ladies and gentlemen, I'm going to be writing here. Né? So now I'm going to add angle O1 plus O2, which gives me O1 is 2 angle B1, and then O2 is 2 angle, what? B2, right? And then, but remember angle O1 and O2, when you add them, they're giving you AOC, I mean. Né? So I'm going to replace this part to AOC. They give me that whole thing there. So this is AOC is equals to, here there's a common factor of 2, so I can take it out. Angle B1 plus, here I'm left with angle B2. And then AOC equals to 2. Remember, B1 plus B2 gives you the whole of angle B. When you add this and that, you get the whole of angle B, which is there, right? Then your reason will be proven in bracket. And then you're done with this theorem. Thank you very much, ladies and gentlemen.